Hi there, folks. Today we're looking at complex probability. And complex probability really just means that we have to use permutations or combinations to come up with the number of ways that something can happen or the total number of possibilities. All right. See, previous to today, we did simple probability. And in all the simple probability type of examples, we were able to simply count the number of favorable outcomes. We were simply able to count the number of total possibilities and then come up with our fraction for probability, which was the favorable over the total. But now, if we're in a situation where basically we can't just count the number of possibilities, we have to use a permutation or a combination or even the fundamental counting principle to come up with the number of possibilities, or we have to do the permutations or combinations of the fundamental counting principle to come up with the total number of possibilities, then it's complex probability, all right? We're still finding probability the same way. We're still doing what I want over the total number, but I might have to do a permutation or a combination to figure out how many ways can I get what I want. I might have to do a permutation or combination to figure out the total number of possibilities. And so really it's just merging those two ideas together. When you think about simple probability and you think about finding the number of possible outcomes, when we put these kind of things together, that's when we get complex probability. And once again, the easiest way to tell whether it's simple or complex, is look at how many things are happening at once, all right? If I'm pulling one marble at a time, it is simple probability. But if I'm pulling a fistful of marbles out all at once, now it's complex. That's when I have to use permutations and combinations, all right? That's the subtle difference. So if I'm pulling marbles out of a jar, if it says I want to pull a red one out and then a blue one, that implies one at a time. I'm pulling one marble out, then the next marble, then the next marble. That's simple probabilities. I go right to setting up fractions. I can count the number of possibilities. But if it says, hey, I want 2 greens and 1 blue marble, well, that implies that I'm just reaching there and pulling 3 marbles out at once. Okay. And so that's when we have to go to something like combinations instead of just counting the number of possibilities. Okay. For example, so here I have 32 audio files on your phone or something like that. 18 of them are classic rock and 14 are random cloud noises because I believe that is the future of music, obviously. If you pick 3 songs at random, what is the probability that they're all classic rock? Okay, and so instead of counting the number of possibilities, this is one that I actually could do from the perspective of simple probabilities, but just approaching it from the perspective of complex probabilities, think about how we would figure out if I ask the question, how many ways? So if I had this situation that says, how many ways can I get 3 songs that are all classic rock? You would say, well, that's a combination because I don't care what order they're in. It doesn't say that we're arranging them. So it's the combination of, well, there are 18 classic rock, and I want 3 of them, so it would be the combination of 18, choose 3. That would give me how many ways I can get 3 classic rock songs. Well, if I want to do this in terms of probability, I put the number of ways I can get what I want over the total number of options. So the total number of options, once again, it's a combination. And I think about the total number of options. Think about the situation. I have 32 total things, and I'm picking 3 of them. See, the 18 choose 3 is what I want. I want to pick 3 of those 18, all right? But the 32 choose 3 is what's actually happening. It's the total number of possibilities. There's a total of 32, and I'm picking 3. And now this becomes a job for my calculator. I've just got my Casio pulled up here. Again, you can do this on the TIs if you want as well. Remember, you go into that math menu. So 18 choose 3 is 816. And then here 32 choose 3 is 4,960. And now from here, we have to reduce this thing. You can reduce it by hand, or let's make the calculator do a little bit of work. If I just do 816 divided by the 4960, and yes, you can use the fraction button or whatever if you want, but not all calculators have that. If you hit enter, gives this to you as a decimal. On the Casio here, you see this little button that says F and D with a little arrow. That converts back and forth. On the TIs, you hit the math button and the very first thing has a little arrow and then frac. It means convert to a fraction, and it'll reduce this thing for you. So 51 over 310. But again, we're doing the same thing that we've always done with probability. How many ways can I get what I want over the total number of outcomes? But now I have to use combinations to figure out how many ways can I get what I want. I have to use a combination to figure out the total number of possibilities, okay? And now this is a pretty simple one because we were only choosing one thing. If we look at this guy, a little bit different. So here it says you have 25 marbles in a jar, 10 blue, 7 red, and 8 green. If 5 are selected at random, what is the probability that you select 2 blue, 2 red, and 1 green? And so again, you want to take this from the perspective of combinations. Think about choosing 2 blue marbles. It's the combination of, well, there's 10 marbles, 10 blue marbles, and I want 2 of them. And then I have to do a combination for the red marbles. Well, the red marbles, there are 7 of those, and I want 2 of them. And then for the green marbles, there's 8 of those, and I want 1 of them. And what I'm going to do with these combinations, I'm going to multiply them. And there's 2 reasons you can think of for multiplying them. First is this is an and type of situation. And means that we multiply. Or really, it's the fundamental counting principle. See, when I say I want the number of ways that I could get 2 of the blue, 2 red, and 1 green, I'm saying, hey, the 10 choose 2 is how many ways I can get 2 blue. The 7 choose 2 is how many ways I can get 2 red. The 8 choose 1 is how many ways I can get 1 green. If I want to know the number of possibilities together, the fundamental counting principle says I multiply those things. So that's how many ways I can get what I want. I need to put that over the total number of possibilities. So that's the combination of 25, and I'm picking 5 total marbles. Choose 5. Okay? And then once again, this is a job for my calculator, although some of these we could do in our head. The 10 choose 2 is going to be a 45. The 7 choose 2 is going to be a 21. And the 8 choose 1 is going to be an 8. The 25 choose 5 I can't do in my head, so we'll plug that one into the calculator. And I don't blame you if you can't do those in your head. That's okay. So we got 53,130. And once again, let my calculator do the work here. 45 times 21 times 8. So that's 7,560. And then divided by the 53,130. And then I'll convert that to a fraction. So I get 36 over 253. Really, the most difficult part here is setting it up. It's coming up with the combinations. The math itself is easy because the calculator is going to do most of the work for us. Okay? It's about figuring out the situation, make sure you have a combination set up for each thing that you need to choose, make sure you know whether you're supposed to be multiplying or adding or that kind of stuff, and then setting up your total number of possibilities as well. Okay? For this one, it says a red, orange, blue, green, and purple bead are to be arranged on a keychain. If selected at random, what is the probability that the arrangement starts with an orange bead? And so this one is a little bit trickier because when you think about the number of ways we can get what I want, if you think about these 5 slots, there's one slot here and then 1, 2, 3, 4, 5. Okay, so those are my 5 beads. If I'm going to start with an orange bead, so if this one's going to be orange, so that one's kind of already picked for us, all right? That one's going to be an orange, which means I only have the choice for these last, I put 6 of them here, but these last 4, all right? And so when you think about the ways I can get what I want, there's only 4 more choices. And again, a range, that's a permutation. So the ways I can get what I want would be 4, choose 4. See, there's only 4 colors left. There's only 4 beads left, and I want to pick all 4 of them to put in a specific order. That's how many ways I can get what I want. Over the total number of possibilities, well, the total number of possibilities, if I didn't have any of these predetermined and said, hey, I've got 5 beads, I can put any of them in any order. So it's the permutation of 5, choose 5. Okay? And so again, I'm just having to go back and think about the situation the way I would when I was finding the number of possibilities. Okay? And so this one's the permutation of 4, choose 4, which is going to be 24. I don't know why I'm punching it into the calculator. And this one down here is going to be a 120, but I'll punch it in anyway. And don't worry, don't be scared by my amazing math skills. All right? But now, again, let the calculator do the work. You could probably reduce this one by hand, and it wouldn't be that big of a deal. Looks like 1/5. Okay? So the probability of having an arrangement that starts with an orange, 1/5. Okay? But again, we're just using permutations and combinations to come up with those possibilities. if I look at these guys, see in the previous examples, I literally saw the word and in some of those, all right? And so that middle example, the one with the marbles on the previous page, literally had the word and, so I knew it was supposed to multiply. But sometimes the words and the word or will be implied. And we kind of saw that sometimes with simple probability, all right? But this time we really have to imagine the situation. We have to kind of write it out, all right? That's going to be the key to doing each of these, all right? So for example, a game has 5 green, 5 blue, 5 red, and 5 yellow cards. If you draw 2 cards, what is the probability that exactly 2 of your cards are red? All right. And notice there's no and written here. There's no or written here. So we have to just kind of think about the situation. If I have 5 cards in my hand and I want exactly 2 red cards, it means I want a red card and another red card. Sorry, I should literally write the word and here. And I want 3 more cards, but those cards can't be red, all right? So I want 3 more cards that are not red, all right? If that makes sense. So when I kind of start thinking about this situation, I can condense these 2 reds here and really kind of think about my hand this way. I want 2 red cards and 3 not red cards, all right? And see, that word and is kind of implied here if you just think about the situation. But now what I have to do is I have to come up with a combination. So if I want to choose 2 red cards, well, that's the combination. There's 5 red cards, and I want to pick 2 of them. So for choosing 2 red cards, that's the combination of 5, choose 2. For 3 not red cards, well, I got to think about that in terms of a combination. How many not red cards do I have? Well, there's 15. And how many of those 15 do I want? Well, I want 3 of them, okay? So the 5 choose 2 is for 2 red cards. The 15 choose 3 is for 3 cards that are not red. All right. And now we see the word and here, which tells me to multiply these combinations. Okay. In the previous example that we had an and, the and was written, so I knew I had to multiply. But again, it's still my fundamental counting principle. All right. And now I think about the total number of possibilities. Well, there's a total of 20 cards, and I'm picking a total of 5 of those cards. So the total number of options would be 20, choose 5. Okay, so again, that numerator is what I want, all right? So I have to think about the combinations for getting what I want. The denominator is more like what is actually happening. And what's actually happening is there's 20 cards and I'm picking 5 of them, okay? And now once again, this is a job for my calculator. This guy gives me a 10. The rest of these, I'm going to use the calculator to do it. 455 for this guy. Down here, the 20, choose 5. Thank goodness for calculators. Can you imagine punching this in every time? And doing that formula every time? That would be crazy. And so up here, let's see, I've got 4,550 when I multiply the 10 and the 455 divided by the 15,504. And I'm going to convert that to a fraction. Looks like I get 2,275 over 7752. That's it. That's my probability of this thing happening. Again, I just had to work out the number of possibilities using combinations this time, okay? And you'll find that we tend to use combinations more often than permutations in a lot of these examples. All right. How about this one? It says a class of 7 girls and 6 boys has to pick a 4-student team to represent the class. What is the probability that the team will have at least 2 girls? And so again, I really have to map out this situation and think about it. So if I was picking a student team and it had to have at least 2 girls, that means I could have a team that had, I don't know, 2 girls and 2 boys. Would that be okay? Yeah, that has at least 2 girls, all right? Could I have a team that had 3 boys and 1 girl? Well, no, that doesn't have at least 2, all right? So I could also have a team that would be 3 girls and 1 boy. That would be okay. It says at least 2 girls. That fits the criteria. Or I could have a team that had 4 girls without any boys, all right? And so pay attention to how I would read this kind of as a sentence. I could have a team with 2 girls and 2 boys. Or I could have a team with 3 girls and 1 boy. Or I could have a team with 4 girls. All right. And so you can hear as you read this and you think about the situation, you can hear that there's an implied ands and ors floating around all over the place. Okay. And now each of these things is a combination. All right. So if you think about it, the number of ways that I could get 2 girls would be the combination of 7 choose 2. There's 7 girls, and we want to pick 2 of them for the team. All right. For picking 2 boys, it would be the combination of 6 choose 2 because there's 6 boys, and we want to pick 2 of them for the team. For picking 3 girls, that would be the combination of 7 choose 3. 1 boy would be the combination of 6 choose 1. And 4 girls would be the combination of 7 choose 4. And so I'm just using combinations to determine the number of ways I could get that situation. But now here's the ands and the ors. There was an and here, so that's multiply. There was an or here, so that's add. And was multiply, or was add. And so we just have to think about the situation. And just like when we were doing probabilities, and is multiplication, or is addition. Okay? And now I have to put that over the total number of possibilities. And the total number of possibilities here would be the combination of, well, I just got to think about, I have a total of 13 students, and I'm picking total of 4 for the team. All right. And now it's a job for my calculator. The 7 choose 2 is a 21. The 6 choose 2 is a 15. The 7 choose 3. Let's see, that's a 35. The 6 choose 1 is a 6. And the 7 choose 4 is also a 35. I can do most of those in my head. The 13 choose 4, I'm not sure off the top of my head, so I'm going to say, let's plug that into the calculator. That's a 715. And now my calculator's ready to do the heavy lifting for me. Okay, so I'm going to do the 21 times 15 plus 35 times 6 plus another 35. That's 560 over the 715, and let my calculator convert it to a fraction. So 112 over 143. Whoops, 143. I know how to write a 3. There we go. But again, it's just setting up a combination for each of these things. All right. Let's look at one more here. Again, mapping out the situation is the key to this thing. All right. So there are 10 milk chocolate and 8 dark chocolate candies in a bowl. If 4 are selected at random, what is the probability that you will select at most 2 dark chocolate? And so at most means that many or less, okay? I don't want any more than that. So 2 dark chocolates, that means, so I'm selecting 4. I could have 2 dark chocolates and 2 milk chocolates. Or I could have 1 dark chocolate, because I don't want more than 2 dark chocolates. I want that many or less. And 3 milk chocolates. Or I could have no dark chocolates and just get all milk chocolates. So 4 milk chocolates. Okay. And so again, think about the situation. It's 2 dark and 2 milk chocolates. Or, okay, one of this and. So listen for those ands and those ors. Those tell us about multiplication or addition. And now it's just combinations. To get 2 dark chocolates, well, there's 8 of those, so it's 8 choose 2. The number of ways I can get 2 milk chocolates would be 10 choose 2. 1 dark chocolate would be 8 choose 1. 3 milk chocolates would be 10 choose 4. 3. I'm getting ahead of myself. And then here, that would be 10 choose 4. Okay? And again, this was an and, this was an or, this was an and, this was an or. Okay? I'm converting that statement into a mathematical kind of sentence with combinations, multiplication, and addition. And then the total number of possibilities, once again, it's a combination. There are 18 total candies, and I'm picking 4 of them, so it's 18 choose 4. And now, once again, this is a job for my calculator. The 8 choose 2 is a 28. I can do that one. The 10 choose 2 is a 45. 8 choose 1 is an 8. The 10 choose 3 is a little tricky. I think it's I want to say 120. I'm doing it very quickly in my head. Yep, 120. And then I'll do the 10 choose 4 on here as well. And again, I just know the formula well enough. It's not any kind of magic that I'm using to come up with those. I just know the formula well enough and know how to reduce some of these things fast enough that I don't need to punch them into the calculator. But if you need to, that's okay. I would expect most of you to plug all of these into the calculator. So 30, 60. And now let's finish it off with the calculator here. So let's see, 28 times 45 plus 8 times 120 plus 210. So it's 2430 over the 3060, so divided by the 3060, and then let the calculator convert it to a fraction for you. 27 over 34. That's it. Complex probability just means we have to use permutations and combinations to come up with the number of outcomes. Okay?